So good afternoon and welcome to GE's Aviation Inspection Technologies Challenge webinar. Please note, due to technical difficulties, the live webinar recording from 1:13 was lost, so we are re-recording the webinar to ensure that the solution providers interested in this challenge have the resources they need to submit a proposal. As this is being recorded at a later date, please note that we will be providing the live Q&A from 1:13 in written form with this recording on the forum. Those who ask questions will find the answers in transcribed form. Additionally, if you watch this recording, please note you can ask any additional questions you have in the challenge forum on the challenge website. So without any further notes, let's get started. My name is Casey Shapiro, and I will be your host and moderator for this webinar. So now I'm going to briefly go through the agenda. First, we're going to provide the speaker introductions. Then we'll provide an overview of the challenge. After that, we'll present the frequently asked questions of the challenge. Then, as stated earlier, the live Q&A will be provided in transcribed form, so we will not be going through the questions live. And then to finish, we will wrap up the information on what you can do today for the challenge, including where to register, how to stay connected, and how to submit your proposal. So now I'm pleased to welcome the following speakers to our webinar this morning. From GE, we have Lisa Ralph, Open Innovation Operations and FastWorks Integration Leader, and Wayne Spence, Chief Manufacturing Engineer, Rotating Parts and Airfoils Value Stream. And then from 9 Sigma, we have Paul Massili, Program Manager. The topic of today's webinar is GE's High Accuracy, High Throughput Inspection Technologies Challenge. 9 Sigma, representing the General Electric Company, invites proposals describing technologies, processes, or approaches that can increase the speed and accuracy of aviation parts inspection. So now we're going to hear from Lisa Ralph on GE's vision for this challenge. Lisa?
Great. Thanks so much, Casey. And everyone, welcome back, and thank you for listening to our re-recording. My name is Lisa Ralph, and I am the Open Innovation Operations and FastWorks Integration Leader at GE Corporate's Open Innovation Center of Excellence. So that is a lot of words, but what do I do really? I am responsible for scanning the landscape inside GE to look at what are we doing, what are our business needs outside of our walls, to say what's happening within the world, what does the landscape look like, and being able to pair the two together. So I'm codifying a lot of best practices, a lot of processes, and then what I'm doing on a day-to-day basis is actually running and managing a variety of campaigns across our business portfolio. So Open Innovation at GE. Open Innovation is something that is new for us. The mere thought of looking outside our walls after 125 plus years is something that's a little bit novel, shall we say, but it's also something that is incredibly exciting. It's really allowing us to collaborate with brilliant people like you guys who were on the webinar before and listening today in our forum on some of our highest value, highest priority problems. It's really throwing the status quo of what we've been doing out the window, and again, allowing us to perforate the walls of our constraints and reframe what's possible, redefine what's possible, as we've said here. And to really underscore that, it's not just about the ideas. Ideas are great, we'd love to see them, but what we really want to do is be able to execute on them, be able to bring them to life. So here, with GE, your ability to look at our highest value problems through a new lens that is yours, not ours, 125-year way, can be hugely impactful because of the potential scale when implementing your solutions. So what we're talking about here is it's across our industrial businesses. We are a conglomerate, so there's a lot of opportunity for cross-pollination at huge scale. We are one of the largest companies in the world, and therefore we make a lot of stuff. So it has a lot of places to be applied, and then as well across the globe. We're actually in over 170 countries across the world. So what I personally think is neat, though, about these opportunities to collaborate with GE is that because of this massive scale, because of the global reach, that your solutions can literally have the chance or potential to be impacting and improving the lives of tens of thousands, if not hundreds of thousands of people all over the world. So not too shabby for a day or a couple of days of work. So really, for you listening here, and then for us as GE, this opportunity to partner together is something that we are super excited about, being able to partner on our toughest challenges. It's really a charge to develop better, to develop more efficient outcomes. So together, we can define tomorrow today. So that's a very nice, very pretty 500-foot view of our stance of open innovation. But as great as that is, what does that actually mean? How can we bring it down a notch to something that's a little more accessible and relevant? And the way we're doing that is through aviation. So if you switch to the next slide, we're actually here today beginning our journey with this high accuracy, high throughput inspection technologies challenge. So as I mentioned on or in the previous slide, open innovation is something that we are choosing to apply to our highest value priorities. So high accuracy, high throughput inspection technologies, why is this one of them? First off, GE Aviation has a huge installed base. I believe there were about 33,000 commercial engines in operation in 2013. And that number is one that is only continuing to grow at an ever-increasing rate, which means it's thereby increasing the pressure to inspect the key components more quickly, as well as maintaining or improving accuracy. So what this means is that we need to inspect more components at higher efficiency while providing the same or improved level of service. So this really parlays into our second reason this is such an important, meaty challenge. And that's something that probably is not all that, what would the word be, unusual, given it's an aviation challenge, but that's safety. So as you can imagine, as the number of commercial engines grows, so does the number of components that go into them. And thus maintaining the accuracy on each and every of those parts is absolutely critical, because safety and compliance are something that is a non-negotiable in this industry. So currently, for your reference, components are precision crafted to tight tolerances, and then they're actually individually inspected for compliance. So that is a lot of work when you're considering an installed base of tens of thousands that is continuing to grow and grow and grow. So it's a big job. It's a very big job, but it's actually one of our most important, which is why we're so excited to see what you have here. So what we're seeking from you are new technologies, new methods to inspect the components more efficiently and, more importantly, accurately. So to reinforce what I was saying earlier, when applied at scale, your solution here has the opportunity to save an immense number of hours through that manufacturing process, which we know is expanding, as well as keep all those passengers, goods, etc., on those thousands of planes in operation safe. So obviously, a very meaty, impactful challenge in terms of its application. But one thing I'd like to mention here, and something I find actually really interesting in this challenge, and I run many of them, so something that's very unique, is the fact that the team is actually using a physical artifact, so that paring knife that you'll see written throughout the website to substantiate your proposal. So in the very beginning, I said, theories and ideas are great, but what we're here for is to really make it happen, to do. So we're really committed to creating real outcomes. So again, what pairs really well with this challenge and what's compelling here is that it's an opportunity to literally show off your stuff and do.
Great, thank you so much, Lisa. Now we're going to go ahead and turn it over to Wayne, who's going to review the technical goals of the challenge. Wayne?
Yes, hello, thank you, Lisa. Thanks, Stacy. What I would like to do is kind of walk you through the artifact that we're going to use And a little background, though, on me. Again, my name is Wayne Spence, and I'm a Chief Manufacturing Engineer in aviation. And what I do in this large, what we call value streams, we make rotating parts in all the airfoils, is guide the strategic, path of our value stream, which includes all of our inspection technologies as well. And as Lisa mentioned, our airfoils are becoming very, very harder to make. They're very tight tolerance, low surface finishes. In other words, they're shiny. And we want to inspect every one of these, and we make millions of new ones a year. So it's critical to us to have a full data set of every one of these airfoils so we can continue to improve our process and to also help the customer when it comes from performance. So we contemplated how we could handle giving you something to use your process on, and we obviously couldn't send our airfoils all over the planet. So a gentleman had a great idea of using a knife, and you see a knife here on the screen, and it's not an exact replica, of course, of an airfoil, but it gives us something that we can all shoot for. It is shiny, it's relatively thin, it has sharp edges. So what you see on this screen is where our minimum type of inspection requirements. Now, obviously, we would like to have the entire surface of the knife, not counting the handle, inspected if possible. But what we do in our shops to save time is a compromise. We pick 5 equally spaced sections, usually it's on a drawing, 5 equally spaced sections along the airfoil, in this case along the knife, pretty much equally spaced, where you would do a complete inspection around that section. So, you have to pay a lot of attention on the leading edges and the trailing edges, of course, and, of course, across the surface. So that's just the reason we go to minimum of 5 sections. The more, the better, but if you can hit the 3 minutes target and do it at a minimum of 5 sections, that is really tremendous. So, of course, the denser the data set is, the more accuracy you're going to have. So that's really critical as well. All right. So next page. All right, so to really emphasize the leading edges, and this is just on the top right you see some just basic pictures of our airfoils. Of course, it's a cartoon. But the way this usually works with all the current technologies that we're looking at is if you follow the green points with an orange line through, that's basically the actual surface of this airfoil, and the green points is where the machine touched to measure the location. The blue lines represent basically the tolerance band of where it could be and still be acceptable. So this is a typical thing that you'd see, and this is blown up hundreds of times, obviously, around a leading edge. And, of course, you can see the density of the points get a little tight around the leading edge. This is the typical thing that we do. We have to do it to get as much data as we can on this, but we're reaching the limit of how fast and, of course, even more importantly, how accurate we can be to what the truth is of that airfoil. So this is just something for you to contemplate as you're looking at your own technologies of what we're doing today and how we really emphasize the edges. Okay, next page. And so, here's just a snapshot of all the different processes, different equipment, different suppliers that we've evaluated, we're either using, not using through time, and it just shows how extensive it is, our research and our supply base is. Now, we have pretty good suppliers now, but again, we're looking for something that may just be the next generation of inspecting technology of airfoils. And everybody should be in this game. Everybody from scanning like CMMs that's already in the game to any type of optical solutions, who knows, eddy current solutions. There could be many, many different solutions out there, and that's why we're coming to this type of crowdsourcing concept, is because we want to give everybody in the world that's got something on a workbench an opportunity to be able to take a shot at this. So, the thing and you can, a lot of this information here that you see is it's open information, it's public information. You can go to these companies' brochures, web pages, and you can get a lot more technical data that might be able to help guide you, kind of bound what you're thinking you know, and how good you have to be and how fast you got to be. So, again, we pick this type of thing like inspecting of airfoils because it's manageable in size, we believe. It's not an overwhelming capital cost. It's not like monster mills or anything like that. And we believe there's a lot of people that has things already. So I also want to emphasize, clearly, many of you will be able to actually do inspection data and turn it in per the challenge requirements. But I really, really, really recommend that everybody, if you have a concept that you really think has a great opportunity to get here, you just don't have the time to get to the data, still turn that in. We always follow up on great ideas and concepts and work with you. You won't be obviously eligible to win the challenge, the awards, but you clearly can be in the game for, you know, something big later as well, as if your concept works out and we end up working with you for your inspection technology. So again, don't be totally discouraged if you can't get there to the data set. Okay, so that's what I have. I guess I'll turn it back over.
Thank you so much, Wayne. So now we're going to go ahead and work through the challenge FAQs. So the first one is, when is the deadline to submit an entry?
So the deadline to submit your entry will be February 24th, 2015 at 5 p.m. Eastern Time. So just want to point out that this is an extra couple weeks. We anticipate that you know, people would like a little bit of extra time to finish collecting their data and working on their submissions. So we went ahead and extended that deadline to make sure everyone has enough time to get in their submissions.
Great. And how do I submit an entry?
You can submit your entry online through the digital form at the challenge webpage listed here, and which will also be available through a link later as you're looking at this.
And when will GE announce the winners?
So GE is going to have an internal team of experts review all the entries, and after they're finished with this review, they'll announce the challenge winners in May of 2015.
Great. And what should I include in my entry?
So entries are asked to have an inspection data set that includes both description of the equipment and the amount of time it took to do the inspection. This should come in an ACSII data file that you can attach with your submission at the online form.
Great. And where can I ask more questions after this webinar?
So the challenge forum is a great place to ask these questions. Just go ahead and post your question there, and I'll work with the GE team to make sure that the correct answer gets posted there, and other people can benefit from the answer to your question as well.
Great. So as I said earlier, we will not be working through the live Q&A at this point, but you will be able to find that on the challenge forum with this recording. If you have any additional questions, just like Paul said, add them to the challenge forum and we'll provide the answers as soon as possible. So to wrap up, what can you do today? You would want to visit the challenge website, which is listed in this link on the screen. You want to go there to register to receive updates, view the FAQs, and join the community. You'll want to stay connected at the community forum that we keep mentioning. It's there at the link on the screen. Like I said, you can also use that to continue to ask any additional questions that you might have. And then, of course, you want to submit your proposal. The deadlines for submissions, as we said earlier, is February 24th, 2015 at 5 p.m. Eastern Standard Time. So that concludes our webinar. For additional information, again, we encourage you to visit that challenge website. And then, as Paul stated earlier, please, and as I just stated, please note that the deadline for submissions has been extended to February 24th, 2015. Thank you so much for listening, and thank you again to our speakers for their time and expertise and for joining us again to help re-record this. We appreciate your time and look forward to receiving your submissions. Thank you so much and have a great day.